Today I'm going to show you in this video how you can create linear and exponential models in Excel using some population growth data from the World Bank for the country of Angola. First, open up an internet browser. Next, type in the following shortcut URL: http://tiny.cc/13YSTW, and then hit enter. This is going to take you to the World Bank, which is a very reputable organization that shares data with governmental organizations, private charities, businesses, law firms. It's widely respected as being reliable and unbiased. Click on Download Data. Click on Excel File. Click on Save. And why don't you save it to your desktop? That way you'll be able to find it more easily. Open up the spreadsheet. Click on Enable Editing if this virus protection warning comes up. Click on the worksheet tab that says Sheet 1. Okay, in this example, we're only going to need the data for Angola. Each of you will have your own country that you are going to get data for. So you will be clicking on different numbers on the left side here, depending on which country that you need data for. So all of you will first click on the row right below the header row, which is 2. So click right on the 2, and then scroll down to whatever country you have. And then you're going to click on the row right above your country. You're going to shift click on the number that's right above the number for your country. Shift click. Then you're going to right click in the blue area, and you're going to scroll down and left click on delete. So now your country should be the country that's right underneath country name. Next, you're going to click on the row right below your country. And then you're going to scroll down to the very end of the spreadsheet. Then you're going to left click on the last row of data and right click in the blue area, scroll down and left click on delete. Now you have just the data that you need. Next, you're going to insert a scatter plot, and the very first type of scatter plot. Next, you're going to want some extra credit, right? So if you can make this all pretty for me, just like you would do in a business or on a job, I'll give you extra credit. Click on Layout. Click on Axis Titles. And for the primary horizontal axis title, you'll want to left click on Title below Axis. A box will open up for you. Triple click in that. 1, 2, 3. And then type years. Go back to Axis Titles, and then click on Primary Vertical Axis Title. And then highlight Vertical Title, or actually Rotated Title. That'll look nicer. Click. Triple click inside, and then type population. Next, you're going to want to make this title look nicer. So you're going to click on the title, triple click to highlight the inside, and you're going to type population change for Angola. And the years are 1960 to 2011. Next, you're going to want to say, where did you get the data? So you're going to create a text box at the bottom. So click on text box, left click on text box, then go down and left click in the upper left hand corner where you're going to put the text box, drag a box, and then type source, whoops, World Bank. Now, if you're really doing this for a business, you'd also include the link where you got the data and some other information. But this is good enough for me. Okay, next we're going to generate our linear and our exponential models. This is how it's done. Click on the curve there. Next, you're going to go to Layout and click on Trend Line, and then left click on Linear Trend Line. And as you'll see, there's a little line that appears. It's a little hard to see, so I suggest you left click on the line itself, right click, and then scroll down to Format Trend Line. And change the line color to solid line. Choose something bright and cheerful, maybe orange or red. I'm going to choose red. And then you're also going to need to left click on trend line options and left click on the boxes before display equation on chart and display R squared value on chart. And then you're going to close. And you're going to click on the linear model, which looks all weird with that crazy plus sign there. That's scientific notation, but you don't have to be worried about that because you're going to change that to something that you can understand. So you're going to scroll down and to Format Trendline Label, and you're going to choose Number, and then you're going to click on the Close button. And so now that scientific notation is turned into regular notation, which produces a very long number, but it's more readable, isn't it? So I moved that over. You can just click on one of these boxes and move them anywhere you want. So I moved it off to the right so that you could see it more easily. And you will do the same for your graph. Next, I'm going to create an exponential model using Excel. I'm going to click on that blue curve again, and I'm going to left click on trend line, and I'm going to scroll down to exponential trend line and left click. Once again, you have a black line that's kind of tricky to see against a blue background, so I recommend that you left click on that curve, right click to Format Trend Line, and change that line color. Left click on line color, left click the solid line button, and then choose something that's not red because you've already used that. So choose some other color that would show up nicely. Maybe green. How about bright green? And you're also going to need to change those trend line options. You're going to want to display the equation on the chart and display the R squared value on chart. And I'll explain what that R squared value means in just a second. Click the close button. Okay, so now you have another crazy looking number with that big E and the plus sign, which is hard to read. So we're going to right click on the box, scroll down to Format Trendline Label, left click, and we're going to left click on Number, and then press the close button. And once again, now we have a number, which is a lot easier to understand, isn't it? Okay, so what is this business about the R squared? What the R squared tells you is how good a fit the model is. And by fit, it is almost exactly what you might say. If you have a good fit for clothes, then they fit snugly and not too loosely, right? Okay, so the closer that the linear line, or the closer that the line is for that model to the actual pattern of the data, in this case it's a curve that looks like that, the closer to 1 r squared will be. So if you'll notice, the line is kind of away from the curve here at the ends, and its r squared value is not as close to 1 as the exponential model's r squared value. And that makes sense because look at the exponential model. That curve almost fits exactly along the blue curve, doesn't it? So that's why its r squared value is closer to 1. So anyway, there we have it. And now it's your turn.